Hello guys, if you've already made it this far, then you've learned what IP addressing is, switching, and also basic device configuration. Then you're ready for the next step. Every device, including your cell phone, has an IP address. And to communicate outside its own network, traffic must pass through a router. Your home Wi-Fi also works as a router that connects you to your ISP, which means internet service provider, or the SIM card you're using on your phone. In today's video, we are moving into layer 3 networking. Yesterday we worked on configuring a multi-layer switch to act as a router. Now we are taking it further by learning inter-VLAN routing, a key concept that allows devices in different VLANs to communicate. I'll show you how this works and why it is important and how to configure it step by step on a Cisco router. Let's get started. What is inter-VLAN routing? It's a method that allows communication between different VLANs. Without inter-VLAN routing, devices in separate VLANs cannot communicate. However, inter-VLAN routing achieves this by using a router or a multi-layer switch. The importance of inter-VLAN routing is it ensures separate networks can exchange data. It also enables segmentation while keeping connectivity, as it improves network management and traffic control. The benefit for inter-VLAN routing is it enhances security through network segmentation, better performance with reduced broadcast traffic, and also flexible design for scalable enterprise network. So with that being said, let's head over to the lab and see how we can configure inter-VLAN routing on a router. So guys, for today's lab, we are going to be using one router, one switch, and 6 PCs, as we also have VLAN 10 for IT, VLAN 20 for HR, and VLAN 30 for sales. We also have our guidelines for today's tutorial. First, we are going to have to create a VLAN on the switch. Guys, I believe you understand that without VLAN, all the devices on a switch can communicate without a VLAN. However, if you assign ports to VLAN, then those devices can no longer communicate. Let's create the VLAN on the switch. So we need VLAN 10. We want to name that IT. We also go for VLAN 20 and we want to name that HR. We also going for VLAN 30 and that's going to be named sales. We've created 3 VLANs. We can check for the VLANs by this command, do show VLAN. Now we have the default VLAN that has all the ports. We also have the 3 VLANs that we've created, VLAN 10, 20, and also VLAN 30. So this is how we check for our VLANs, and we have our 3 VLANs on the network. Now for the next step, we are going to be assigning ports to VLAN. And VLAN 10 takes 2 and 3 ports. How do we assign ports to VLAN? See interface range FA0/2 to 3. We want to say switch port mode should be access. Then we want to say switch port access VLAN 10. Now we've assigned these two ports to VLAN 10. Let's also do the same for 4 and 5. Switch port mode to be accessed, and switch port to access VLAN 20. Let's do the same for the last 6 and 7. Switch port mode to be accessed, and the VLAN to be VLAN 30. Let's also check what we just did. Do show VLAN. Previously we have all the ports in VLAN 1, but now we have 2 ports each for 10, 20 and 30 VLAN that we created. Let's also check what we have on our guideline. So the next on our guideline is to trunk the ports connected to the router, and it also says assignment. Now my assignment for you guys, you can leave the answer in the comments. Why do we have to trunk the port that is connected to a router? Usually we always trunk the port connected to a switch. Now why do we have to trunk the port connected to a router? That is a question. Leave your answer in the comment section. So we have to trunk the interface connected to the router, and we do that by saying interface FA0/1, because that's the port connected to the router. And we want to say switch port mode to be trunked. Now we've trunked the interface connected to the router. Let's say no shot on that interface so it doesn't keep showing red. So interface gig 0/0, no shot. Alright, so the port is up. We've assigned all the ports to their VLANs. Let's check what we have next. Configure inter-VLAN routing on the router interface. Guys, how do we configure inter-VLAN routing on the router interface? This is the main focus for today's video. So what we do is we say interface gig 0/0 dot the VLAN number. This is called sub interface. This is how we make sub interface for a VLAN in a network. So by doing this, as you can see, we are now in a sub interface of the VLAN 10. Take note, guys, for us to assign IP address to this interface, we have to encapsulate .1q for us to assign IP. If we just assign IP to it, so let's give this 10.1 as the default gateway with the subnet mask of 255.255.0. Let's see what's going to happen. We cannot assign IP address to this interface unless we do this first. So encapsulation .1q. Take note, guys. Then at the end, you assign the VLAN number that you want to encapsulate that port to. Now try to assign IP again to the port. Now we are able to assign IP address to VLAN 10 sub interface on the router. Let's do the same configuration for the other VLANs. So VLAN 20, we want to encapsulate to the VLAN number. Then let's assign IP address to that interface. The interface will be 20.0 network, and the default gateway for the sub interface of VLAN 20 is going to be 20.1. Let's also do the same for interface VLAN 30. And it will be taking the IP address of 30.0, and the default gateway will be taking the IP address of 30.1. Now we've assigned IP address to all the sub interface on the router. As you can see over here on the same interface gig 0/0, that is where we have sub interface for VLAN 10 and also sub interface for VLAN 20 and VLAN 30. Now this is the only way that devices that is connected to the same switch but they are in different VLANs. By creating sub interface, this is how the devices can communicate in a network. Now let's verify that by assigning IP address to the host PCs and try to ping. The 192.10.5. Let's copy this. Oops. To 10.1. Let's also assign IP address to this device and try to ping. So 10.6, the default gateway is 10.1. Now let's try to ping between these two PCs here and see if we are able to communicate. So 192.168.10.5. Yes, we are able to communicate with the 10.5 PC. Let's assign IP address to the PCs in VLAN 20. So this takes 20.5. We want to copy that, and this takes 20.1 as the default gateway. Let's also assign IP address to the second PC. Now let's also try to ping from this device to the 20.5 network. So 192.168.20.5, and also they are able to communicate because they are in the same VLAN. Let's try to ping from VLAN 20 to VLAN 10 and see what happens. Yes, of course, it will be able to ping VLAN 10 because we've configured sub interface on the router. Now let's do this. Let's go to the router and remove the sub interface of VLAN 10 and check if VLAN 20 would be able to ping VLAN 10 again. We want to go to interface gig 0/0.10. We want to say no encapsulation dot 1Q. Then there is no more sub interface 10. So guys, yeah, we don't have sub interface 10 anymore. Let's try to ping from VLAN 20 to VLAN 10 and see what happens. You know, before we were able to gain communication, right? So now destination host is unreachable. Let's also try to ping from this device to VLAN. Let's try to ping from VLAN 20, from VLAN 20 to VLAN 30. Remember, we have sub interface configured on VLAN 30. Let's see if it's going to go through. Oh, we've not assigned IP address to the host PCs on VLAN 30. So 30.5, 30.1. So we've assigned IP address to the host PCs on VLAN 30. Let's try to ping devices on the same network. 30.5. Yes, we are able to gain communication to 30.5. Let's try to ping 20.5. We will still be able to gain communication to 20.5 because it has sub interface still configured. Now let's try to ping 10.5. The destination host is still unreachable because we do not have sub interface configured for VLAN 10. And let's do that one more time and try to ping and see what happens. IP add. So we've configured sub interface one more time for VLAN, and let's try to ping from the same device that was not able to reach VLAN 10 earlier. Now it is able to ping or send ICMP packets to VLAN 10. If this video helped you understand how inter-VLAN routing works, how we could create VLANs, assign ports to them, and also create a sub interface on a switch for different VLANs, then why not give me a like and subscribe to this channel so you get to see more tech videos. Thank you guys, and see you in the next.